Imagine a giant world that floats alone. It has no sun, no bright star to warm its surface or paint its sky with dawn. It wanders through the cold, silent emptiness between the stars, a solitary traveler on an endless journey. Scientists have found evidence of these lonely planets. They call them rogue planets. This concept is strange, almost unsettling. A planet that does not orbit any star sounds impossible, a violation of the cosmic order we are so familiar with. Yet they are undeniably real, and their existence forces us to reconsider what a planet can be. Let us meet one of the universe's most profound and loneliest travelers. These worlds are not just a theoretical curiosity. They are a confirmed class of celestial objects. Our galaxy, the Milky Way, is teeming with them, perhaps numbering in the billions or even trillions. Each one is a self-contained system, a kingdom of one. So, what exactly is a rogue planet? In the simplest terms, a rogue planet is a planetary mass object that floats freely in space without being gravitationally bound to any star. Most planets we know, like those in our own solar system, are part of a cosmic family. Earth orbits the Sun, Jupiter orbits the Sun, and so on. These planets are held in predictable paths by their star's immense gravity. A rogue world, however, has broken free from this gravitational leash. It moves on its own, a solitary entity drifting through the vast expanse of the Milky Way, following a lonely trajectory among the stars. This fundamental difference, the absence of a host star, changes everything. Without a sun, a rogue planet receives no significant light or heat. This makes its surface unimaginably cold, potentially hundreds of degrees below zero. Any atmosphere it might have possessed would likely have frozen and fallen like snow, creating a thick mantle of nitrogen, methane, or other frozen gases over a rocky or icy crust. How can a massive world end up so utterly alone? Astronomers believe there are two primary pathways for a planet to become a rogue. The first, and perhaps most dramatic, is through violent ejection. Imagine a young, newly forming star system. It's a chaotic and crowded place, with many young planets, or protoplanets, jostling for position. Their orbits are not yet stable, and they frequently cross paths. In this gravitational dance, the bigger planets hold all the power. A massive gas giant, like a Jupiter-sized world, can act as a cosmic bully, flinging smaller planets around with its powerful gravity. During these chaotic early days, a close encounter can have dramatic consequences. If a smaller, Earth-sized or Neptune-sized planet swings too close to a massive giant, it can be caught in a gravitational slingshot. The larger planet's gravity can accelerate the smaller one to incredible speeds, fast enough to achieve escape velocity from the entire star system. It gets thrown out into the cold, dark void, forever exiled from the light and warmth of its parent star. It then begins its long, lonely journey as a rogue planet, a refugee from a turbulent planetary nursery. The second path is less violent but just as lonely. A planet can form all by itself, far from any star. In the vast, cold, dark molecular clouds that drift between stars, the conditions are sometimes right for gravity to do its work on a smaller scale. While most of these clouds collapse to form stars, smaller, denser clumps of gas and dust can collapse under their own gravity to form objects of planetary mass. These objects are too small to ignite nuclear fusion and become stars, but they are large enough to be considered planets. These born rogue planets never had a star to call home. They formed in isolation, deep within the dark nebulae. Beyond their lonely existence, rogue planets harbor mind-bending secrets that challenge our assumptions about where life could exist. One of the most astonishing possibilities is that some of these cold, dark worlds may host vast, liquid water oceans. While the surface of a rogue planet would be frozen solid, a large enough planet, several times the mass of Earth, could generate significant heat from its core. This internal heat, produced by the decay of radioactive elements, could be trapped beneath a thick, insulating shell of ice, creating a stable, warm environment for a subsurface ocean. In such an ocean, life could potentially arise and thrive, completely independent of a star. This turns the traditional concept of a habitable zone on its head. We usually think life needs to be a certain distance from a star to have liquid water, but a rogue planet suggests that a world's own internal engine could be enough. This hidden ocean would be a world of total darkness, but life there could evolve to use chemical energy from hydrothermal vents on the ocean floor, much like the extremophile organisms found in the deep sea trenches on Earth. Another surprising fact is the sheer potential number of them. Early estimates, based on micro-lensing surveys, controversially suggested that rogue planets could outnumber stars in our galaxy by a significant margin. While more recent studies have revised this number downward, the population is still expected to be immense, numbering in the billions at the very least. The universe is filled with mysteries like this, from wandering planets to the nature of dark matter itself. Exploring these ideas is what makes science so exciting. If you find these strange space stories as fascinating as I do, and you want to continue this journey into the unknown, then please take a moment to support our exploration. Go ahead and hit that subscribe button, give this video a like, share it with someone who you think would have their mind blown by the idea of a planet with no sun. Every subscription, like, and share helps us reach more curious minds and continue creating content that delves into the biggest questions in the cosmos. But I also want to hear from you. The community we build here is just as important as the information we share. So head down to the comments section and let me know, which fact about rogue planets surprised you the most? Was it the idea of a subsurface ocean, or the sheer number of them that might be out there? Your comments fuel the conversation and often bring up amazing questions that we can explore in future videos. Don't be shy. There are no bad questions when you're talking about the universe.